In this video, we are going to talk about how to find zeros of a polynomial by factoring. So let's first talk about a few things. We already talked about that when we have an nth degree polynomial, you'll have at most n x-intercepts. Well, in a complex number system, meaning this includes real and imaginary numbers, when you have an nth degree polynomial, you'll have exactly n zeros. So how do we find those n zeros? So today we're going to talk about how we find them by factoring. So if I look at number 1, first I'm going to factor out a GCF. Because if I look at number 1, I can see that all of these have an x in them. So I'm going to factor out a GCF of x. Now, this doesn't look like something I can factor, but in fact it actually is. I'm going to think about how I factor 2x squared minus 7x minus 4, and then replace, instead of x being x, x is actually going to equal x squared. So in this case, 2x squared would be x times 2x, and then negative 4 would be negative 1 and 4, 1 and negative 4, or negative 2 and 2. So if I'm trying to get negative 7, I think it's going to be negative 4 and positive 1, which if I check, I'll get negative 8x, 1x, which will be negative 7x. So how this is going to factor is x squared minus 4, and then 2x squared plus 1. Now this can actually factor a little bit more because x squared minus 4 is a difference of perfect squares. So when I factor, it's going to be x times x minus 2, x plus 2 to factor that difference of perfect squares. And then I'm going to have 2x squared plus 1. So this is that polynomial completely factored. Now, how do we find the zeros? Well, again, the zeros are the x-intercepts. So if I think about the zeros, one of my zeros is 0 because of this x. My other 0 is positive 2. My other 0 is negative 2. So let's just rewrite this as plus or minus 2. And then I need to find the zeros for 2x squared plus 1. So 2x squared plus 1 equals 0 is how I find what x would equal. So I end up with 2x squared equals negative 1. X squared equals negative 1/2. Square root both sides. X is going to equal plus or minus the square root of negative 1/2. When you have a negative square root, it becomes 1/2 I. So the other 0 is plus or minus the square root of 1/2 I. And so those would be my 5 zeros for my 5th degree polynomial. All right, let's try the same thing for number 2. So now when I have 4 terms, I'm going to use grouping. So group. GCF of my first pair is x squared. I'll be left with x plus 2. GCF of my second pair is negative 3. So x plus 2. So my fully factored form will be x plus 2 and x squared minus 3. So what are my zeros? Well, I can see from x plus 2, one of my zeros is negative 2. My other 0 is going to come from solving x squared minus 3 equals 0. And when I do that, I'll get plus or minus the square root of 3. So that'll be my 3 zeros for my cubic polynomial. All right, let's look at number 3. Now this looks kind of similar, but it might be one that we don't recognize at first, but this is a difference of perfect squares, excuse me. So really this is x squared minus 1, x squared plus 1. But then my x squared minus 1 is also a difference of perfect squares. So that'll factor into x minus 1, x plus 1, and then x squared plus 1 will stay. So this is the fully factored form. Now what are my zeros? Well, I have positive 1 and negative 1 for my first 2 terms. Then to solve for the zeros, I have to set x squared plus 1 equal to 0. And we're going to get some imaginary numbers. So I'm going to have plus or minus the square root of -1, which we know is just plus or minus I. So those would be my 4 zeros for my 4th power polynomial, my 4th degree polynomial. All right, if we look at number 4, I have a sum of cubes. So how this is going to factor is same sign, square, opposite sign, multiply together, always positive, square the b. So this is the fully factored form. So I can see that one of my zeros is -5. How do I find the other zeros? Well, this is not factorable, so if it's not factorable, we have to use quadratic formula to find the zeros. I know, blast from the past. So opposite b plus or minus the square root of b squared minus 4ac all over 2a. So opposite of b, well, b is already negative, so positive 5 plus or minus -5 squared minus 4 times 1 times 25 all over 2 times 1. So 5 plus or minus the square root of, well, 25 minus 100 is going to give me -75. All right, so how do we reduce that? Square root of -75 is the square root of 75 times the square root of -1. We know the square root of -1 is equal to I. But the square root of 75 will break down into 25 and 3. So the negative square root of 75 will become 5 square root 3i. So my last zero will be 5 plus or minus 5 root 3i all over 2. And that gives me 3 zeros, 1 for the -5 and then 2 because of the plus or minus. So I know I have 3 zeros for my cubic polynomial. All right, so in 4, 5, and 6, I'd like you to try those. So pause the video now and give those 2 a try. When you're ready, play the video. All right, in 5, we got to do a couple types of factoring. First, I see that they are both divisible by 2 and both have an x. So I'm going to take that out first. When I take out the 2x, I'm left with x to the 4th minus 81, which is a difference of perfect cubes. So this will factor into x squared minus 9x squared plus 9. Now this x squared minus 9 is a difference of perfect squares again. Sorry, I think I said cubes. I meant perfect squares. So the fully factored form will look like this. Whew. Well, this is going to have 5 zeros, so let's find them. So first of all, this 2x tells me that my first zero is 0. I have positive 3 and -3 from the x minus 3 and x plus 3. Then I'm going to get my last 0 from setting x squared plus 9 equal to 0. X equals plus or minus the square root of -9. Well, the square root of -9 is 3i. So plus or minus 3i. So 1, 2, 3, 4, 5 zeros, so I know I got them all. All right, let's look at number 6. Now this is similar to the first one, where I want to think about this like a trinomial. So really I'm going to think about it as x squared minus 5x minus 24. And everywhere where I see an x, I'm going to end up replacing it with an x squared. So I need to think about two numbers that multiply to -24 but add to -5. So that'd be -8 and +3. So this will factor into x squared minus 8x squared plus 3. Now x squared minus 8 is not a difference of perfect squares because 8 is not a perfect square. So this will actually be the fully factored form. But then to find my zeros, I'm going to set each one of these equal to 0. Add 8. So plus or minus the square root of 8 Well, that'll break down into 8 is 4 times 2. And so the square root of 4 times the square root of 2 becomes 2 square root 2. So those are 2 of my zeros. Plus or minus square root of negative 3. So that's plus or minus the square root of 3i. And so my zeros are plus or minus 2 root 2 and plus or minus square root of 3i. So let me check really quick. I have 1, 2 zeros here, 2 zeros here. 2 plus 2 is 4, 4th degree. So I have all my zeros.